In class on Wednesday, September 16th, we did a problem which we kind of developed on the fly and actually had an error during the course of that problem. So I want to take this opportunity to redo the problem, hopefully properly, so that you can see how that sets up. We had a ball fall straight down from a tube, and we estimated the height of that tube to be 1.33 meters. And our first task was to understand the kinematics of the ball and identify position, velocity, and acceleration throughout that event. So what do we know? We're going to first set our y-axis to 0 up here, and positive y is upward. So the ball actually starts at time t equals 0, y is 0. The initial velocity, just as the ball is released to fall, it starts at 0. And then as it falls, gravity is pulling it down, so it has a negative 9.8 meters per second squared acceleration. After it falls, the ball is down here just before it touches the ground, and it has a final velocity. So what is the time of that? We don't know. That would be a variable called TF. What is the position of that? Minus 1.33 meters. And what is the velocity at just before it touches the ground? We don't know, but it would be VF. Now in looking at this, I want to use one of our standard 3 equations of constant acceleration to find t. If we look at the first equation, I know v0, I don't know the final t, I know acceleration, and I don't know the final v. So in this situation, I don't have enough information to use that. However, I can use the second equation here. That would allow me to find my time. So let's go over here, and we'll say yf equals y0 plus v0t plus 1/2 at squared. So y0 by definition, where we set it up, was 0, so that goes away. v0 was initially the initial velocity, and that was 0. So we just have the final position equals 1/2 at squared. I know the final position is 1.33 meters in the negative direction. That equals 1/2 times minus 9.8 meters per second squared times TF squared. And solving for TF, we get a time of 0.517 seconds. So that's how long it took to fall. In class we had a much bigger number, like 2.6 seconds or something like that. Okay, so if I go over here and I put in what I know here, that's 0.517 seconds. So now I do have enough information to use equation number 1 to find out what the final velocity is. So V final equals V0 plus AT equals negative 9.8 meters per second squared times 0.517 seconds. The seconds cancel, and VF, the final velocity, would be equal to minus 5.07 seconds, meaning that the ball is falling in the negative direction. It started at 0 meters per second, and after going down about a half a second, about 1.3 meters, its velocity just before it hits the ground is in the negative direction, 5.07 meters per second. Okay. Now the problem was actually that the ball was initially shot to the right with an initial velocity v0x. We don't know how fast that is, but what that did was that made the ball move to the right as it fell down. And so as the ball moves to the right while it falls down, it actually has a parabolic trajectory. So let's see why that is. First of all, what do we know? I know that in the downward direction I have gravity, so I have negative 9.8 meters per second squared of acceleration. Horizontally, though, there's no forces acting on the ball after it's been shot. Once it leaves that spring-loaded shooter, then there's no forces acting on it, so I know that my acceleration in the x direction equals 0. So that means that the ball is traveling always at the same speed in the horizontal direction, so at any given point here it has a horizontal velocity of v0x. I don't know that value, but I do know that it's the same as when it started. Okay, so let's go to our table and figure out what we've got here. At time t equals 0, we had the same exact parameters as we did before in the previous problem. Whether the ball falls straight down or is shot to the right, in the vertical direction it does the same thing. So that means I know the ball hits the ground at 0.517 seconds, and I know the final position is minus 1.33 meters, and I know the final velocity is 5.07 meters per second. So these are the answers from the previous problem. What else do I know? Well, in the x direction, I've defined my axis so that I start at x equals 0. I know there's no acceleration. I don't know what the velocity is, but I know it's the same. So over here, I start with a position of 0. I have a velocity of v0x. I have a final velocity of v0x. And I have no acceleration. Okay. Now I also don't know my final position in the x value in the horizontal direction as I fall. So there's two things I don't know. So in the vertical direction we have an situation of constant acceleration. In the horizontal direction, though, there's no acceleration, so we have a situation of constant velocity. So let's see what we know in that situation. Well, we do know that v equals delta x over delta t. And so what do I know? I don't know my initial velocity, and I actually don't know xf, so I don't know my displacement, delta x. I do know delta t goes from 0 seconds to 0.517 seconds. So with what we actually know, I cannot solve any of the problems because I don't have enough information. What I need is to know, where did the ball land? Okay, and we didn't measure that in class, but let's make an estimate of xf equals 1.2 meters. Now let's see what that equals then, if we can figure out what's going on. I have a final position of 1.2 meters minus my initial position divided by my final time minus my initial time. And when I solve this, I get a horizontal velocity of v0x equals 2.32 meters per second. Okay, so now let's fill out our table. We have a position now, so that is now 1.2 meters, and that was a guesstimate, a measurement, so that's a given, not something that we calculated. And then we have an initial and final velocity that are the same, 2.32 meters per second. So there you have it. And again, it's important to realize in the vertical direction, this is a problem of constant acceleration. In the horizontal direction, this is a problem of constant velocity, 0 acceleration.